Hello everyone, let's talk about another easy problem on Leetcode today. Remove duplicates from sorted list. Leetcode number 83. I think we have already covered remove duplicates from the sorted array. And this is just the similar solution in the list. It says that given the head of the sorted list, delete all the duplicates such that element appear only once. Return the linked list sorted as well. So it says that whenever we see the element, like in this case, 1 and 1 two times, or even more than one time, then we will just keep the element only once. So for example, in this example, now we see that in example 2, we can see that it's retained. We retain 1, 2, and 3. So the order of the list stays the same. It's just that the what you say duplicates have been removed. And if you remember, I think before going into the solution space, just another problem can be sometimes this list may not be sorted, right? So in this case, we may have to use some data structure like hash map or something, like first iterate over the list, find out all the duplicates, and then create a new list um, out of that, and maybe we can still retain some ordering there as well. But here the problem is simple because the the list is already sorted, and we don't have to worry about like any extra data structure. Now let's jump into, and this is actually more about iteration and how do you like write the loop, and how do you deal with the pointers. So let's jump into the solution space. So if you remember the problem where we were deleting the duplicates from the sorted array, we have to maintain two pointers. One was like a right pointer, which where we were just iterating over the over the array, and the left was more or less keeping track of what you say the non-duplicate elements that we have explored from the explored part of the array. Luckily, in case of linked list, we don't have to worry about the two pointers because linked list has one value and the next pointer. So why not use it? So what we can do is like in this case, current pointer will be like our left side of the things where we just move when we ascertain that okay, this element or this value is actually not a duplicate. But right pointer will again try to explore the list and see if we actually find the what you say a duplicate, or what kind of element is it. So what we can do is like initially we can our current will point to the head, and then what you say current dot next will be 2, right? So we see is 1 equal to 2, and the answer is no, because like current is equal to current dot next and the answer is no. So we will move the current, and now our current will be here, but our current next will be one step ahead. So again we check, is current equal to current dot well is equal to current dot next dot well, and the answer is yes. So in this case what we will do is like we will move current to current dot next, because and by when we are doing this, this is our next, right? But what we are doing actually here is like um, we are moving our next to one by skipping one row, sorry, one node from the linked list, and this will be somewhere garbage collected, or depending on the programming language, cleaned up somehow from the system. And now we will get the linked list like this. So again, current is still pointing to 2, so it's not like current has moved, only the current dot next has moved, because we have to ensure that we find the new element in the list. That's what right pointer or current dot next is doing for us. Now we see 2 is not equal to 3. Then we again move current to here and current dot next to here now. So again we see all the values are same, so we will keep on moving current dot next, and eventually we will reach null. So our current will stay at this point, and now, but our linked list is now clean, and we can again return the head pointer because we just modified the linked list in place, and that should be the solution. Now let's jump into the code part. As discussed earlier, I think what we can do is like we have to just worry about the current dot next, right, pointer. And let's read the constraint just before doing that. So it says like we can have lists in the range of 0 to 300, and the value will be in the range of -100 to 100. So and they are assigned in the ascending order. So because we will just be caring about left and right pointer, so what we should care about is, like, if we have only one element in the list, then we don't have to worry about anything, right? So either head is equal to null, that means there is none element, no element. In case if head dot next is equal to null, that means we have only one element. So we will just return head in this case, right? Otherwise, what we will do is, like, uh, we will set current to head, so treat it like a left pointer, and now we will start exploring the list using current dot next, aka right pointer. So we will just check while current dot next is not equal to null, right? Till that point, we will just keep on exploring. And now if current dot well is equal to current dot next dot well, that means, and by the way, I think current dot next will not be null, right? That's why we will be able to get the I think value. And I think this is important, that we don't get any null pointers when we are working with the list problems. And we will just do okay, then move the current to current dot next to current dot next dot next. That's it. And otherwise, like, if they are not equal, we have to just move our current to current dot next. That's it. And we will just continue this loop, and eventually we can return the same head. I think this should work. Let's try it out. Okay, let's now submit the problem. Awesome. Yeah, so I think that's the solution. And I think in terms of time complexity, because we are going through all the elements in the list, it will take O of n time. And in terms of space complexity, we are not using any extra space, so I think it's O of 1. I hope you guys like the solution. Please, if you do, please like and subscribe. Have a nice day.